Hi, in this video, I will perform radar plotting method number 4, multiple targets, course alteration and reducing speed for collision avoidance. For R given, your vessel is on course 340 degrees true with a speed of 15 knots. Targets were observed with the following data as follows. For the time at 10:10 hours, target alpha had a bearing of 290 degrees true with a distance of 11.0 miles, while target Bravo at that particular time had a bearing of 010 degrees true with a distance of 11.0 miles. Target Charlie at that same time bore 050 degrees true and a distance of 11.0 miles. At 10:22 hours, bearing of target alpha 290 degrees true with a distance of 8.5 miles. Target Bravo, the same bearing, 010 degrees true with a distance of 8.0 miles. Target Charlie, bore 050 degrees true with a distance of 8.0 miles. At exactly 10:30 hours, that's your TMX, establish your RMX to all targets and execute your course of action as follows. Letter A, to alter course to 020 degrees true, new on course. Letter B, to reduce speed simultaneously to 12 knots. That's your NOS. So that you will let the targets pass ahead and astern of your vessel. For your required, which of the three targets is the most dangerous target based in Colregs? And letter B, the following data below. For targets A, B, and C, the DRM, SRM, RMX, new DRM, new SRM, new BCPA, new time of CPA, and new range of CPA. And now to proceed with our plotting process. Let's go. First up will be your course. Your course set to 340 degrees true. And the bearing of the first observed target is 290 degrees true, followed by target Bravo, 010 degrees true, and target Charlie, 050 degrees true. After placing all the bearings and your course, all you have to do is measure the distance of target Alpha, target Bravo, and target Charlie. So based on the given distance of target alpha, 100 hours is 11 miles, measure 11 miles. Target Bravo is also 11. Target Charlie is also 11. The next would be the distance of target Alpha. Second observed distance is 8.5. So measure 8.5 in your scale. Place it at target Alpha. The next, target Bravo and target Charlie, 8 miles. The next would be for you to encircle the distances of the three targets. So this will be target Alpha, this will be target Bravo, and this will be target Charlie. Next, to place your own ships, course. Own course is 340 degrees true. So on speed is 15, and your time interval to use is 12 minutes. So 15 times 12 divided by 60 would give you 3 miles. So 15 and 12, 3 miles. So measure 3 miles in your scale. So this will be your distance of your own ship. Label E and R. And to complete it, all you have to do is just label all the targets R and M, R to M, R and M. The next thing we should do is bring our own course line here. That is 340. We'll bring this to the three targets. By aligning your triangle. Just align your triangle in this manner and move it sideways towards target alpha. And draw a line. Followed by target Bravo. Followed by target Charlie. The next would be place the distance, same distance here, your own ship. Place it on at R of the three targets and draw an arc. So that's gonna be your distance. And to complete your triangle, label it as E, here as E, and also as E. And just darken it up with your pen. So here, your pen. And Charlie, also with your pen. So that when you erase later on, it will not be removed. Just erase the excess. Since we are required to solve to get our DRM, so for target alpha, just align it. This will be the DRM of alpha. For target bravo, will be the DRM of bravo. And for target Charlie, so this will be the DRM of target Charlie. And just label it. So this will be the DRM of target Charlie. That is 230 degrees true. This will be the DRM of target Bravo. So this is 190 degrees true. This will be the DRM of target Alpha. So that's 110 degrees true. The next process would be, so we now have our DRM, target Alpha, target Bravo, and for target Charlie. So Alpha is 110, Bravo is 190, Charlie is 230 degrees true. And we are to solve for our SRM. To solve for our SRM, we have our formula. Distance from R to M divided by the time interval. So all you have to do is measure the distance, or perhaps just subtract the distance. Distance of the first observed and the second observed. So that's going to be the distance from R to M. So 11 minus 8.5 would give us 2.5 miles. Next, for target Bravo, 11 minus 8, that's going to be 3 miles. For target Charlie, so 11 minus 8, that's also 3 miles. This will be the distances from R to M of the three target vessels. To continue with your computation for the SRM, so we now have our distance from R to M divided by the time interval, that is 12 minutes. So 2.5 divided by 12 minutes multiplied by 60 would give us 12.4, 12.5 knots. So the SRM for target alpha will be 12.5 knots. For target Bravo, so 12 minutes, and the distance that is 3 miles. So 12 minutes and 3 miles. So 15 knots. So 15 knots for target Bravo and target Charlie. It's also 15 knots. The next process would be to solve for our RMX. So since our given is the TMX, that is 10 per T100 hours. So to solve for travel time, M towards MX. So here we have the formula. To solve for the travel time, since TMX is given, that is 10 per T100 hours, minus the last observed time, that is 10/2200 hours. So that would be 8 minutes. So we will be using 8 minutes to solve for the distance for RMX. So distance from M towards MX would be equal to SRM multiplied by the travel time, that is 8, divided by 60. So we have to solve for each target. So let's start with target alpha. So for target alpha, the SRM is 12.5 multiplied by 8 minutes divided by 60. So the distance would be 1.6. Distance from M to MX of target alpha is 1.6. So 1.6 miles. So for target Bravo, we're using the same formula. So SRM for target Bravo. So 15 multiplied by 8 divided by 60 would give us 2 miles. 2 miles. For target Charlie, also 2 miles, since they have the same SRM. So for target Alpha, that's 1.6. Target Bravo and target Charlie, 2 miles. So the next process would be all you have to do is measure 1.6, since the distance that target Alpha will cover is 1.6 in 8 minutes. So measure 1.6 here in your scale and place it. So this will be your MX, because the TMX is 1030. M is at 1022. Since each scale is equivalent to 2 miles, so obviously all you have to do is just place, circle it here. So this will now be your MX for Bravo. This will now be the MX for Charlie. So having the same TMX, that is 10 per T100 hours. So here your TMX is a 10 per T100 hours. So the next process would be for us to get that RMX. In order to do so, all you have to do is measure the distance from E to MX, or better yet, distance from M minus the distance from M to MX. So the distance from M for target alpha is 8.5 minus 1.6. So that's obviously 6.9. So the RMX here is 6.9 miles for alpha. For target Bravo, so obviously it's 2, 4, 6. It's 6 miles. So the RMX for target Bravo is 6 miles. Also the same with the RMX of target Charlie, which is also 6 miles. So the RMX for Alpha, that is 6.9 nautical miles. Target Bravo is 6.0 nautical miles. Target Charlie is 6.0 nautical miles. Next, we'll be determining the new DRM. So in order to do so, we have our new on course. It is set to 020 degrees true. New on course is 020. Take note, 020 is here. So that's gonna be our new course to steer. This will be our new course to steer. So we'll bring this 020 to all of the targets at E of the three targets. Place one triangle, align it with 020, since that's gonna be your new course to steer, and slide it. First, we'll have to start with target alpha. See to it that your supporting triangle is fixed. So even though your moving triangle eventually move, so there's no problem since your supporting triangle here is fixed. And adjust, draw a line. Next, proceed to target Bravo. Draw a line. Proceed to target Charlie. If you have to slide, see to it that it is aligned, perfectly aligned with, you have to slide, see to it that it is aligned, perfectly aligned with 020 degrees, and move your triangle downwards towards E of target Charlie and draw a line. So we now have our new on course. The next would be to get our new on speed. To determine the distance, since we'll be reducing our speed as we alter our course to 020. So to get the distance of E to R1, all you have to do is multiply your new on speed by the time interval. That's 12 minutes. So we'll be using 12 knots multiplied by 12 minutes divided by 60. So your distance would be 2.4. So that's gonna be 2.4 nautical miles. So new on speed, that is 12 divided by, or sorry, 12 times 12 minutes divided by 60 would give us 2.4. So 2.4 for all the three targets. So all you have to do is measure using your compass divider. Measure 2.4. And place it first, target alpha. Next would be a target Bravo. And next would be a target Charlie. So label this as your R prime. R prime. R prime. R prime. Now all you have to do is just darken the line here from R towards MX. From R towards MX. R towards mx. Okay, we now have r mx. We now have r1. So for the next process would be, we're still not done yet. To get our new DRM, all you have to do is connect R1 to M. Just have to connect R1 to M of the three targets. R1 to M, R1 to M, R1 to M. The next process, we will have to bring R1 to M to R MX to determine the new DRM. So you have to do it one at a time, one target at a time. So first, let's start with target Charlie, depending on your preference. Heteroiodine. And next, bring it to E. So this will now be the new DRM of target Charlie. That is 252 degrees true. Five, 1, 2, 252 degrees true. Next for target Bravo. Target Bravo. Use the same process. Connect R1 to M and bring it to MX here. That's the point of execution. And draw a line. Next, place it at E. So, by the way, this will be the new RML of Charlie. So this eventually will become the new RML of Bravo. So this will be the new DRM of Bravo. That's 2, 28, 228, 228 degrees true. And the other one, this is target alpha. Move it towards MX. And move it towards the center of E. For label, this will be the new RML of target alpha. This will be the new DRM of target alpha, that is 128 degrees true. The next, so we now have our new DRM. New DRM of alpha is 128. New DRM of Bravo is 228. New DRM of Charlie is 252. The next process would be our new SRM, but first, before doing that, we have to get our new bearing of CPA of the three targets, Alpha, Bravo, and Charlie. So new DRM plus 90 of Bravo. This is the new bearing of CPA of Bravo here. Sorry for that. The next would be for target Alpha. 128 plus 90 would give us 218. So 218. So the new bearing of CPA of target Alpha, that is 218 degrees true. So this will be the new CPA here. And lastly, for target Charlie. Target Charlie, 252, 342. So that's 342 degrees true. 252 plus 90 would give us 342 degrees. So this one will be the new CPA for target Charlie. New bearing CPA of target Charlie, that is 342 degrees true. So new SRM, new bearing of CPA of Alpha, 218. New bearing of CPA of Bravo is 318. New bearing of CPA of Charlie is 342. So to solve for our new SRM, all you have to do is measure this distance. Measure the distance, R1 to M. So this is 4.2 for target Charlie. For target Bravo, 3.2. For target Alpha, 6.6. So 0.6. So 0.6. So all you have to do is just solve. So 0.6. 0.6. 0.6 is the distance divided by 12 times 60 would give us 3. The new SRM of Alpha is 3 knots. For Bravo, 3.2 divided by 12 minutes times 60 would give us 16. 16 knots. So for target Charlie, 4.2 divided by 12 times 60 would give us 21. 21 knots. Next, to solve for the new time of CPA. New time of CPA. given the formula, TMX plus the travel time. So we have to solve for the travel time of each target. That is, travel time from MX towards the new CPA. But first, we have to measure the distance of the three targets from MX towards new CPA. Six point eight. 6.8 for alpha. Bravo. So 4.7 for Charlie. 5.6. So 5.6 miles. So solve the distance, that is 6.8 divided by the speed or the new SRM. So 6.8 divided by 3, 2 hours. 2 hours and 15 minutes. So 2 hours and 15. So that's gonna be 2 hours and 15 minutes plus the time at MX. 2 hours plus 15. 2 hours 16 minutes 10:30 would give us 12:46. So 12:46 for target B, 4.7. Have your formula here. So 4.7, that's 4.7 divided by your new SRM, 16 times 60, 18 minutes. So 10:30 plus 18, that's gonna be 10:48. 100 hours. Letter C, 10:46. For the new range of CPA, all you have to do is just measure the distance here. That's it. So this is 2.4 for Bravo. 0.9 and for Alpha. So that's it. 2 miles for Alpha, 3.9 for Bravo, and 2.4 for Charlie. Okay, for the next items, for the remaining two. To get the target through force and target through speed, all you have to do is just connect E to M. E to M, target Bravo, and the E to M of Alpha. The next process would be to bring this to the center to determine the force. By placing one triangle here, E towards M, Slide it towards the center. E2M. And draw a line. So this will be target true course of alpha. That is 0, 3, 2. 0, 3, 2 degrees true. Next for target Bravo, E towards M. So E to M. Target true course of Bravo is 271. 271. Next, target true course of Charlie. So these are bonus items. Target true course of Charlie, that is 2902. For Bravo. Sorry, for this is Bravo, sorry. 271 for Bravo. For Alpha, Alpha is here. So that's 032. For Charlie, that's 290. This is 032. Alpha is here. Bravo. And Charlie. For the target true speed, all you have to do is just measure the distance from E to M. So that's 3.5. For Bravo, measure the distance. 1.7. That's 1.7. Right. 4. It's 2.3. 2.3, 1.7, and 3.5 to get the speed, target true speed. So given your formula here, target true speed, that is distance from E to M divided by the time interval times 60. So 2.3 divided by 12 multiplied by 60 would give us 11.5. So 11.5 knots. For target Bravo, that's 1.7. 1.7 divided by 12. 60 would give us 8.5. 8.5 knots. And for target Charlie, 3.5. 3.5 divided by 12 times 60 would give us 17.5. So 17.5 nuts. So this is how we plot. Method number 4. Multiple targets in radar plotting. Force alteration and reducing speed. So for the answer key, it's given here. Here you have your answer. So the most dangerous target is Charlie, since 12 miles away from our vessel. For the answers, so you have all the answers here. You just screenshot the answer or pause this and counter check your plotting just to verify your work. Thank you so much for watching. Please do not forget to click the like button and click to subscribe. So thank you so much. Do hope you learned in this method number 4 multiple targets video. Bye bye.